This is lesson 14, day 5 of notes. We'll have enough information now to fully finish the worksheet and the top 4 problems. So, it's a little broken up here. I do believe that I have that convert to rectangular as on the next slide as well. Yes. So, here we go. I am given now a point in polar form that has a radius and an angle to turn to. So the first thing you should do, obviously, is plot the point. So it's just kind of following the same ideas that we have used already. And number 2 is make that triangle again. Once you have your point out in space, you will have to make a triangle with the point, the origin, and the x-axis. It's a no-brainer. Okay? Now, here's the thing. This time, you don't have the x and y or the I and j. That's what we're trying to find. So therefore, you know the hypotenuse, and you know the angle. You should know theta. Now, you got to be careful. If you're not in quadrant 1, the theta that you are using or to graph the point is not necessarily if it's not in first quadrant, then it won't be the angle inside your triangle. It'll be the angle to get there. And so when I say label the angle and the radius is fine. That's your answer, always positive. But the angle inside your triangle has to be the reference angle. The angle that's left over gets you back to that x-axis. So if you think about it, if you have a 120-degree turn, right? I'll draw a thing here. If I go 120 degrees, it's somewhere about here, yeah? But this is 120 degrees. My triangle will be here, right? What's the angle inside then? What's the leftovers to get me back to the x-axis? How many degrees straight across?
180.
180. How much is left if 120 is eaten up?
650.
60. Wow. It'd be a 60-degree angle inside my triangle. So, you either have to subtract it from 180, you might have to subtract 180 from it. It matters which quadrant you are in. And also something with 360. So once we got our triangle labeled and the radius placed on our triangle, you now only have to use sine and cosine to find your x and y values. Because according to your angle, like in our picture here, it's 60, we have our adjacent and we have our opposite, and we should know the hypotenuse. That would be given as part of the point. And so if I'm given a hypotenuse and an angle, I can use sine and cosine to find the opposite and adjacent sides. I cannot use tangent, because tangent needs both an opposite and adjacent, or one or the other to find the other, because you need 2 of the 3 pieces to solve. And you won't have that. And then once you have your x and y, you technically can write it in the proper I and j hat form. I'll put little hats on there. Hat. Oops. So I hat and j hat. The really cool thing, guys, there's only one answer. There are no 4 answers for this one. Once you find x and y, it's like the x in front of I and then the y in front of the j hat. And you're done. Okay, so now we have to convert this to rectangular. It's polar form, -5 with the angle of -237 degrees. Whoa. This is not a nice angle as in nice and neat where it comes out to a nice number or easy to picture sometimes. So I draw my axes in. Now, I kind of analyze some of this stuff before I just dive in. It's a -5 radius. So therefore, I know I'm going to do what?
backward.
It's going to go backwards. I'm going to walk backwards from the line I am looking. So when I move the negative 237 degrees, I am going to look in that direction, but backpedal backwards. And so, where is a negative 237 degrees? Well, we know this far would be 90. This far would be 180. And if I went a whole nother 90, I'd have to be where? 270, right? This is 270 right here. Negative. I don't want to go that far, right? I'm at 180, a negative 180. 270 would be too far, so I got to be somewhere in the middle. Yeah?
Yeah.
Doesn't have to be exact. But I know that I'm probably going to go somewhere about here. And so, there I'm looking. And when I'm looking in a direction, I like to put the dotted line, yeah? Okay. So I'm looking in that direction, but which way am I actually going? Backwards. I am going backward. 5, whatever, meters, centimeters, doesn't matter. It's according to what the problem's asking us to do. So there is my point at the end. Okay? The cool thing about when we're graphing in polar form is it's already drawn is my hypotenuse. So all I have to do now is go straight to the x-axis to form a right angle, and I've got my triangle.
Wow.
That is a 5, and it's not negative because it's a radius, and all radii are positive. I'm covering a positive distance. Okay? So the negative told me I just had to walk backwards. But I do still cover a positive distance. Now, here's the thing. If I was on the xy plane, coordinate system, this would be x, that would be y, correct? We know that x is going to be positive, but y will have to be negative because I'm going down. We also need to label the angle right here. That's theta. But I know what theta is in a roundabout way. I just need to find it. Find it using deduction here for the fact that that angle would also be the same as the one in the second quadrant, yes? Because those are vertical angles. That's the one I'm going to find. Does everybody see that I went past the fourth quadrant to the third quadrant and I stopped into the second quadrant? We should realize that this is a negative 180 degrees. We talked about that when we started to graph it. And then I went a little bit further. That little bit further is the angle that we want. So how do I find that angle? How many degrees backwards did I go? 237. How much is at the point where it's a straight line? 180. So can I take 237 and subtract 180 from it? You end up with a 57 degrees. So that means the angle, not 3, but 7, the angle from the x-axis in our triangle that's on the other side is 57 degrees.
Contact me mail.
Okay, now we found that this angle here is 57 degrees, bless you. That means our angle over here is also 57 degrees. That's the theta we are going to work with. That's theta. Now, look at this, guys. I have an angle, and I have the hypotenuse. If I was to use SOHCAHTOA, TOA would need opposite and adjacent. And according to 57 degrees, y is the opposite, x is the adjacent. So opposite, adjacent, hypotenuse. I don't know what the opposite and I don't know what the adjacent is. So therefore, I am not even going to consider TOA or tangent. But I do have an hypotenuse and I do have the angle. So that means both of those will work. And the cool thing about it is that in each situation, I am given the hypotenuse, yes, because it's there, that's 5. And each one of those, I know the angle, so that covers the sine and the cosine part of theta. Theta is 57. So all I have left is an opposite and adjacent, that's the unknown. So I'll use sine and I'll use cosine separately to solve for x and y. So let's do that. Let's set them up. So we'll start with sine. Sine of 57. 57, guys, is in my triangle. That is a reference angle. Sine of 57 is going to equal what? What is sine? Opposite over hypotenuse. What's the opposite?
Y.
It's y
Over 5.
over 5. So to solve for y, I multiply both sides by 5. So y equals 5 times the sine of 57 degrees. Make sure you are in degrees on your calculator. Take your calculator out, figure this out. And we get y equals 4.19. So we get 4.19 or 4.2. Matters how you're rounding. We're going to do the same thing with cosine. Cosine of 57 is equal to x over 5. Multiply both sides by 5 because it cancels with that to get x by itself. So x is equal to 5 cosine 57 or 2.72. Now wait a minute, wait. Those are both positive. We said what about y? It has to be negative. So I am going to go and place a negative sign in front of the y because I know I'm going down. The final thing, guys, is I have to write it in I hat and j hat form. And to do that, what does it look like?
2.72
Hat minus 4.19 j hat. That, guys, is the only answer because there's only one point in rectangular form to get there where there is multiple ways to get there using polar form. The whole idea is to plot it, find the reference angle that goes inside your triangle, and use sine and cosine, solve for x and y. Write it, make sure your signs are correct. Your homework then is to do problems 1 through 4 by conversion on your worksheet. Have a fantastic day. Guys, I'm posting your project on Haiku. You guys want to see it quick? It's due the Monday after Thanksgiving. So a week and a half?
I have a confirmation meeting on Sunday.
Don't wait till Sunday. I mean, you guys have pretty good amount of time.
It's kind of mean. Sign something over
No,
Thanksgiving break.
you have all of the rest of this week.
Oh yeah, true. Okay, that's alright. I'll do that.
I don't get it. Don't wait till the end.
I won't. I didn't last time.
So this is what it's going to be. Monday and Tuesday.
And Wednesday. But Wednesday we don't really have class. Other side, it was already taught for you. There you go.
I opened
Better off in... What does that say? So what? What does that say? I can't even read that.
Better off in school.
So what?
See ya.